Well, thanks. And good morning. I'm going to just start us off with a quick scenario here. Just imagine it's 2 a.m. and your phone erupts with alerts. Thousands of business transactions are failing and your applications are down. Are you wondering, is my failover going to work? Or will my application even run in the other region? Are your engineers frantically searching for recovery runbooks, half awake, executing procedures you tested a year ago? For some of you, this may sound all too familiar. I see a lot of smiles in the crowd. For others, you're waiting for that day to come, because it's going to come. So whether you're exploring what it takes to go multi-region or looking to improve your own multi-region approach, welcome to ARC404, building resilient multi-region applications with Capital One. I'm Daniel Sill, along with my colleague Eduardo and Prem from Capital One, and we'll show you how to deliver predictable recovery when it matters most. There's been nearly a decade of multi-region talks at reInvent that shows how best practices and approaches have evolved over the years. And we're back again. Because these challenges haven't changed dramatically, but our solutions have become more integrated and sophisticated. Today, we'll talk about 3 of those challenges and how practical strategies, along with new AWS capabilities, can help you solve these problems. Prem and I will start with the foundation needed for successful recovery. We'll talk about dependencies, often overlooked until it causes your recovery to fail, and share how Capital One identifies these critical dependencies. Then we'll explore recovery orchestration using AWS Application Recovery Controller Region Switch and Capital One's journey with multi-region recovery. Eduardo will come up and wrap us up on data consistency, still one of the hardest aspects of multi-region design. He'll demonstrate how Aurora DSQL and DynamoDB Multi-Region Strong Consistency can enable true active-active architectures. Hopefully you'll leave today with practical knowledge on identifying your dependencies, implementing reliable recovery, and making informed data consistency decisions. But first, let's talk about when you should consider going multi-region. We're up to 38 AWS regions and counting, each resilient and designed to operate independently as fault isolation boundaries. For most applications, a well-designed multi-Z architecture within a single region is going to be sufficient enough for resilience. For applications with the highest availability requirements, multi-region architectures can provide additional protection, but it comes with increased cost and complexity. It requires ongoing investment, not only technology, but in people and processes. So I want you to carefully consider, does my business continuity needs require a multi-region approach? And for many of our customers, it does. And we typically see 2 reasons. You may be an industry that has regulatory and compliance requirements that dictate you need geographic separation for disaster recovery. Financial services, healthcare, and government customers often fall into this category. Or you might have applications that need predictable, bounded recovery in the rare event of a regional disruption. These are typically critical applications where extended downtime can create significant business impact. We're fortunate to have Capital One joining us today. They've been on this journey for years and have developed innovative approaches to build and operate multi-region applications at scale.
Thank you, Daniel. As Daniel just mentioned, at Capital One,
Go ahead.
okay. Can you hear now? Okay, awesome. As Daniel mentioned, at Capital One, our multi-region journey was around by both factors. As a financial institution, we have regulatory requirements around geographical distribution and recovery capabilities. But beyond compliance, we recognize that our customer depend on continuous access to their financial information and ability to make transaction at any time. Hello everyone. Hope you all having a great time at this reInvent. I'm Prem Kumar Dayalan, Senior Distinguished Engineer for Enterprise Resiliency and Recovery at Capital One. I'm glad to be here and presenting this topic. With AWS, our cloud-based environment operates on a massive scale, managing over thousands of applications deployed across thousands of AWS accounts. This infrastructure includes millions of AWS resources and supports thousands upon thousands of critical workloads. Our approach has evolved from treating multi-region as a specialized DR capability to making it a fundamental part of our application architecture. We call it Bond Platinum. This shift allowed us to not only meet regulatory requirements, but also deliver a more sophisticated and reliable experience for our customers. A key part of our success has been centralizing and automating best practices. We don't leave it to the individual teams to figure out multi-region solutions on their own. Instead, we created platform capabilities and guardrails that make the right way the easy way. What I'll share today isn't theoretical. It's based on years of practical experience operating mission-critical applications across multi-regions. Now I'll have Daniel and I will talk through the first challenge.
All right. You probably have experienced this already, but dependencies can ruin your recovery plans. And I hear this often, and it usually is the same story. We try to recover or fail over to the other region, but we had a dependency on X, and X was unavailable because it was in the primary region still. A single overlooked dependency, whether it's a hard-coded endpoint or a third-party API, can turn into extended downtime. In our multi-region fundamentals paper, if you haven't read it yet, it's a QR code here, we talk about understanding your dependencies. And you can think about them in 4 categories. AWS services that must be available in your target region, because not all AWS services or features are available in every region. Internal systems, such as shared services or on-premises components. These might include your authentication services or other business systems that your applications depend on. Third-party services, like identity providers or other SaaS applications. I've seen it increasingly become really critical in most organizations today. And finally, configuration requirements, including service quotas and secrets. These need to be consistent across both regions to support failover. And so if any of these dependencies are not available, it could cause your recovery to fail. What I see often is the challenge is really how do you identify these dependencies? Because they're not core components of your application. If you think about your architecture diagram, they often don't show up on them, right? And so it's often out of sight and out of mind. So I like to use this mental model to think about these dependency categories, either as recovery dependencies or runtime dependencies. So think about the critical dependencies you need to recover your application in a different region. Once they're recovered, what runtime dependencies do they need to operate normally, such as upstream or downstream services that need to be in the same region? So I'll start with AWS services. And knowing which services and features are available in the target region is crucial. And we just made that easier. We recently announced AWS Capabilities, a new addition to AWS Builder Center that gives you visibility into the AWS services across our global infrastructure. You can compare regions side by side, filter for specific services or features, API operations, and even CloudFormation resources. You can use this tool now to ensure that you have parity for your services and features across your AWS regions. For the remaining dependencies, let's take a look at this multi-region architecture. Here we have an application deployed in the primary region. What you don't really think about is its dependent components, likely managed by a different team. And so when you're planning for regional disruption, it's easy to think about only recovering your application in that other region. But what about all the dependencies the app has? Are any of them critical for recovery? Is the application you're recovering in the secondary region dependent on any services that are in the paired primary region? Now your recovery has failed because these dependencies were either overlooked, unknown, or assumed they'll be available because it always worked during DR testing. So how do you know what recovery dependencies are needed? Images to scaled containers, secrets or credentials to connect to databases. So one practical way you can do is start off with your recovery runbook to determine what service or tools that you need to execute every step in your recovery plan. Then you can take it a step further. Once you identify those dependencies, you can do the dependency chain mapping to understand what dependencies does your dependency have. And so by doing this, you've at least identified the known but overlooked dependencies. But that's sort of the easy part, right? What's hard is like, what's hidden? What about the unknown ones that you don't know about? That might be tribal knowledge that somebody had known 15 years ago and they've left the company since. One way you can identify these hidden dependencies is to block network traffic between both your AWS regions during a failover test. You can use a purpose-built test, like AWS Fault Injection Service's cross-region connectivity scenario, which does just that. You can use this scenario to find hidden cross-region dependencies and validate that traffic is not going from the primary region to the secondary region during a failover test. What it does is deny cross-region traffic, access to AWS public endpoints, and access to your workloads via load balancer and API gateways. It will also pause cross-region replication to see how you handle data reconciliation. So the goal really is, during a failure scenario, there should be no dependencies between the primary region and the secondary region, as we saw. So to achieve this, design for regional independence. Because what you want to do is ensure your critical dependencies are available in each region. For some organizations, these capabilities are often provided by a central platform team. So consider operating that platform in an active-active strategy so that's always available. A couple benefits to this is that you can always support applications that fail over during testing at any time without coordination, or during an actual event. You don't have to actually wait for the platform to recover first, thus extending your recovery time. An important one too is if you're using a SaaS provider that's also hosted in the same AWS region, make sure they also have a multi-region strategy. To ensure this regional independence, you should continue to use FIS cross-region connectivity scenario as part of your regular testing to validate there's no traffic going between both AWS regions during a failover. Now, runtime dependencies are just as important, and I'll have Prem come back and talk about how Capital One does runtime dependency management.
Thanks, Daniel. So the runtime dependencies represents the highest tier of complexity and risk, and they relies on coordinated availability of multi-services. Consider this example, such as bill payment. The single process is achieved through chain sequence of transactions. The client requests bill pay, which initiates the business process. Balance API acts as an upstream dependency to validate funds. Scheduler API manages the orchestration and timing of the transaction. Print check API executes the core business action. Update API and DB operation represents the downstream dependencies critical for state persistence and final record update. As you can imagine, the failure in any one single link within this chain, for example, bill payment balance API timeout or scheduler API fails to communicate or commit, results in the complete failure of the business process. This highlights just how complex the upstream and downstream dependency challenges can be in the large systems. Over the years, we found that the most dangerous dependencies are often undocumented, existing only as a tribal knowledge, or the implicit dependencies that were created years ago and forgotten. In our early multi-region implementations, we focused heavily on the technical aspects of replication and failover, but underestimated the complexity of dependency management. In our recovery exercises, we discovered numerous hidden dependencies that prevented the application functioning correctly in the secondary region. Those humbling experiences taught us a critical lessons to evolve. Lack of visibility leads to cascading impacts. There is no single source for the complete dependency chain or the precise recovery order, which makes the impact analysis and appropriate remediation action harder. Furthermore, a significant hurdle in determining the appropriate actions to take on each dependency. The other significant challenge is the difference between the dependencies declared during design versus observed in the live traffic. Without proper dependency management, you risk major business impact and longer downtime during incidents. Incomplete visibility leads to delayed reaction time when responding to failures. Dependency information quickly becomes outdated as applications constantly evolve. These failed recovery exercises led us to develop a sophisticated approach to dependency management using melt data, metrics, errors, logs, and traces. Our process begins with collecting a high volume of diverse melt data directly from our AWS resources and applications. The data allow us to analyze live traffic in tracks to generate and maintain accurate application dependencies. We correlate this data and apply the context enrichment to identify complex dependencies, achieving deep visibility. We map all the upstream, downstream dependencies, assigning critical and factoring in the resiliency tier for prioritization. This comprehensive data-driven map is persisted and used as our core intelligence and determine the correct and sequential recovery during automated recovery. This data-driven approach has been a game changer for us, moving us from static, potential outdated dependency management to a dynamic, accurate view of how our system actually interact. This is a high-level view. The solution flow look like from an AWS resource to melt data collection and enrich with the context, forming detailed application dependency tree. This platform offers flexible views, including infrastructure, API dependencies, and component views, and many more. To summarize our key takeaways on the dependencies, identify hidden recovery dependencies through testing and analysis. Don't assume your documentation is complete. Continuously monitor and update. Identify all the runtime dependencies for end-to-end operations. Look beyond what's needed and consider what's required to function over time. Ensure regional independence to avoid cascading failures so that a problem in one region doesn't affect your ability to operate in another. Based on our experience, I would emphasize that dependency management isn't a one-time exercise. It's an ongoing process. At Capital One, we continuously monitor and update our dependency maps as application evolve. We found that automated approaches like melt data analysis, which we discussed earlier, are essential for keeping dependency information correct and accurate. Now that
Thanks, Prem.
Thanks.
So now that we've identified critical dependencies, I kind of think of that as a pre-recovery, things that you have to do beforehand, before you actually need to failover, right? And so now, when it's time to actually failover, how do you orchestrate recovery into another region? You need a reliable recovery mechanism to coordinate a sequence of steps for regional failover. As Prem kind of talked about, when we understand what these dependencies look like, Whether it's applications or services, often they need to get failed over in a particular sequence. This is where I see a lot of organizations struggle, using manual processes still, or repurposing deployment pipelines that weren't designed for recovery scenarios. So here you see a typical regional failover. It requires more than just flipping DNS to the other region. It needs an automated approach involving multiple steps that needs to be executed in the correct sequence. In this sample architecture, if there was a disruption in the primary region, we would perform the following recovery steps in the standby region. Scale up compute resources, we'd scale up our data streams, fail over our databases, and then we would probably do some application verification in between, right? Maybe application configuration or validating your service and your application works, and then flipping over DNS traffic so that clients can continue to operate and go to the other region. So maybe you have these capabilities already today, but they're painful for a few reasons. Many customers still manually work through a list of steps from the recovery runbook, whether it's ClickOps or executing handcrafted scripts to failover. This approach is error-prone and takes more time coordinating between different operators, making sure that they're going in the correct sequence. Reliability is critical as well. Your recovery tool needs to be available when you need it to be most, which means it shouldn't have a dependency on the primary region. And not only that, but your recovery plan is only as good as the last time you tested it. Very similar to your backup plans, right? So without continuous validation, you risk discovering broken permissions or configuration issues during the failover. Then when executing a recovery, it's often unclear where you're in the process, what's succeeded and what's failed. Lack of real-time visibility can impact your recovery time. So I'm excited to share that in August 2025, we launched a new capability for AWS Application Recovery Controller called Region Switch. We built it to provide customers a fully managed, highly available orchestration service to switch between regions to address the very challenges that we just talked about. It's a reliable mechanism for two reasons. First, it performs a plan evaluation every 30 minutes to ensure that your recovery plan will work when it needs to most. And second, the recovery plan is actually executed from the target region that you're going to, so there's no dependency on the region that you're leaving that may be impaired. It provides automation that eliminates the need to build and maintain custom recovery tools. So let me show you how to build an automated workflow in a region switch plan that reduces recovery time and human error. I've taken the application recovery process that we just saw and built this workflow for it. Here, we use the term activate to fail over to the passive region and deactivate to prevent traffic from going to an unhealthy region for active-active architectures. Every box you see represents an execution block, a step in your recovery workflow. And execution blocks can run sequentially, like steps 0, 3, and 4, or in parallel, like steps 1 and 2. We start off with a manual approval to allow human in the loop to make the decision to fail over, but the rest is automated. Region switch plans are also flexible, so you can build nested workflows for complex scenarios to fail over groups of dependent applications. So whether they're groups of microservices that you have together or groups of applications that need to move over together, you can coordinate all that with the plan. So if we take a closer look at the execution blocks, the first thing that we did was scale up compute capacity in the target region to take on failover traffic. This execution block is an ECS service scaling action that increases the number of tasks in the target region. But how do you know how much to scale up in the target region? Region switch will frequently track the peak running capacity of the source region to allow you to match by percentage in the target region. And that's one of my favorite features. And by the way, it also supports EC2 auto-scaling groups and Elastic Kubernetes service with these same capabilities. For specialized recovery requirements, Region Switch supports a custom action Lambda execution block. This flexibility allows you to incorporate any API-accessible action to your recovery workflow, addressing unique requirements while maintaining the benefits of centralized orchestration and monitoring. What you see here is a Python script I just wrote to scale up Kinesis shards and using its API in the target region. But it's like a Swiss Army knife. You can use it to do the application configuration we talked about or do application verification prior to failing over. So whatever custom code you have, you can use with this execution block. Database is often the complex part of recovery. This execution block makes it simple to fail over the Aurora global database, so you no longer need your DBA to do it. You just need to provide the cluster name and the ARNs, and region switch handles the rest. It even allows you to perform a switchover for planned testing or failover during actual incidents. And then lastly, the Route 53 health check execution block provides a reliable way to route DNS traffic using Route 53 health checks. Here you'll add a hosted zone ID and a DNS record that supports health checks to the execution block. In this example, we're using a DNS failover record that has a primary record in US East 1 and a secondary record in US West 2. Once that execution block is created, region switch is going to generate health checks for each of the DNS records like you see in the diagram below. Then you just copy these health check IDs into the corresponding Route 53 records and associate them. What's important to note is that these health checks are created in an AWS managed account, and they actually don't monitor the resource for your application. Since region switch owns these health checks, it can control DNS routing by changing the health check status to route traffic to the other region on demand as part of your recovery workflow. We use what's called a stop pattern, or secondary takes over primary, and so that way there's no dependency on the primary. Everything is executed from the secondary. That's a quick overview of how region switch works. Hopefully it's going to make your life easier and more reliably to recover applications in another region. I'll have Prem come back one more time to share about how Capital One's has gone through their recovery automation journey over the years.
Thank you, Daniel. At Capital One, our recovery journey begins with slow manual process and isolated component level approach that ignored the broader ecosystem. We recognized this critical gap. At that time, no market solution met our high standard for fast, reliable recovery for business and business continuity. Building an in-house tool was a strategic investment in our resiliency posture. It's been a multi-year journey and a continuous investment. First, we developed automated runbooks, converting static plans into automated operations. Next, we created custom CLI-based runbooks for total flexibility and teamwork. Then we introduced UX experiences with least privilege. This reduced our reliance on the CLI and cut down the human errors. Our plug-and-play phase allowed for quick onboarding and automation for common enterprise cases. Finally, we achieved full maturity end-to-end automation via low-code and no-code workflows. Today, the decisions to failover remains human in the loop, but the execution is fully automated. Remember, we talked about the dependency resolution in the previous section. Here is where we leverage those dependency management for smart, targeted, and sequential recovery. Our preferred and most efficient method is the dependency group failover, though we support individual application failovers too. Our evolution mirrors the maturity journey of many multi-region organizations. That's why we are excited about the AWS Application Recovery Controller region switch. It addresses many of the challenges we solved internally. Our recovery tooling efforts were transformative, cutting recovery times from hours to minutes, and our tools are required common capability across Capital One, and help us to ensure standardization. This consists behavior and eliminates thousands of unique custom solutions and standardized workflow across common tasks, which helps reduce mistakes during incidents and testing events. Second, it significantly reduced the mean time to engage and restore automation and led to faster incident response and recovery. And third, it freezes more capacity, deliver higher business value, and developers spend on the innovation. This transformation has fundamentally changed how we approach resilience, making a core operational capability rather than an afterthought. Our technical recovery exercise provides clear proof of our tooling benefits. Our average minutes to recovery across all resiliency tiers has reduced by estimated 70%. We have more long way to go, but it's a significant, where we started the journey versus where we ended, where we are today is a significant increase from a benefits perspective. This improvement comes from several factors: smoother recovery process, reduced risk from human errors, making it easier for applications to test failover more frequently. This transformation, what were once static dependent document into functional compliance and recovery tools that deliver the real business value. AWS tools and services act as an accelerator for incident response and recovery minimizes impact during disruptions. The slide shows the comprehensive ecosystem of recovery tools we use, for DNS-based routing with Route 53 health check, to traffic management with the global accelerator and elastic load balancing. For disaster recovery, we use combination of AWS services to build the in-house recovery tool, which I talked about earlier. For testing, AWS Fault Injection Service provides resiliency testing capabilities. Although we built our own orchestration capabilities, we are excited about the continuous evolution of AWS services and looking forward to seeing how ARC region switch can use to reduce our operational burden. The key takeaways: implement a reliable automated mechanism like ARC region switch. Don't rely on manual process or repurpose tools which weren't designed for recovery scenarios. An example, CI/CD tooling. We went through that similar journey in the early phase. Ensure your failover process accounts for application dependencies. Understand which components need to move together and what sequence to maintain functional integrity. Test regularly under realistic conditions. Don't test in ideal circumstances. Simulate the chaos and constraints of real incidents. By understanding these elements, you will significantly improve your ability to recover quickly and reliably during regional disruptions, whether planned or unplanned. At Capital One, our experiences has shown the investment in purpose-built tools and orchestrations pay dividends. Just not during incidents, also in the regular testing exercises. The confidence that comes from knowing your recovery process works reliably is invaluable, both from technical team and for the business stakeholders. Now, Eduardo will talk through the third challenge, which is data consistency.
Thank you, Prem. Hello, everybody. My friend Prem talked about the fact that dependency map is the hardest problem, and I agree with him. My name is Eduardo Patrocínio. I'm Principal Solutions Architect here at AWS, supporting Capital One and banking community across AWS. But I want to talk about a different kind of challenges whenever we are building resilience applications on multi-region, and that is data consistency. So Let's go and let's look at some sort of requirement for a credit card authorization system. So this is a fictitious application that I'm building, but it's realistic there. So the requirement that we have here is that we want to process the transactions in less than 500 milliseconds, and then we want to do card validations using the LUN algorithm, validating also the CVV and things like that. And we also want to have some sort of ability to do business logic for the authorization, and then we want to be able to process at least 500 transactions per second with 99.9 uptime. And we want to persist the data with encryption. We want to have RESTful API. We want to do PCI data and things like that. So this is the scenario that I'm going to use to talk about data consistency. So the solution that I built here is still in a single region, single AWS region, spreading across multiple availability zones. And so let me describe a little bit the different components that I have on that solution. So for the data layer, what I do have here is that I'm using Aurora to be able to store the kind of static information. So like the profile of the user, how much the credit balance that, or the credit limit that he has, whether his card is authorized to do international transactions and things like that. So the Aurora database is being used for mostly the profile information. The DynamoDB I'm using to store the transactions there. So anytime that there is some sort of transactions that the user used and the transaction was approved or rejected, I'm going to store on Dynamo. And as I mentioned before, is that I want this solution to be as quick as possible. So in order to make that even faster, I'm using Elastic Cache here in order to provide some way to do in-memory caching of that information. So I'm taking the most recent transactions and bringing from DynamoDB to Elastic Cache. I'm bringing the profile information from the user to Elastic Cache. And my goal with this solution is to do the approval or the rejection as soon as possible. So in order to do that, I'm using ECS Fargate that will come and look at that information, pull information from Elastic Cache, DynamoDB if necessary, and it's just going to come and say, yes, this transaction is approved or rejected. Everything else I'm doing asynchronously, in the sense that I'm going to come and say this transaction was approved or rejected, and asynchronously I'm going to send a transaction to a Kinesis stream, and then there's a Lambda function that's going to pull that information, be able to persist that information back to the DynamoDB table. There. This is cool, but as my friend Dan talked, is that there are many reasons for you to consider doing multi-region, such as different kinds of requirements or different users' experience. So you might have users all over the world or all over the country, and you want to be able to ensure that every user has the kind of same experience. So how do I evolve the solution that I had before in terms of providing a way to do multi-region? So my first step I'm doing those things is that let me take that solution, and hopefully you're using some sort of infrastructure as a code, some sort of CloudFormation or Terraform, that I can just go there and deploy that solution across 2 regions. This is pretty cool, and I'm using 2 kinds of databases here that's helping me to implement this multi-region solution. The first is Aurora Global Database that allows me to be able to replicate the data from one region to another. And similarly is that DynamoDB also has the capability, as you guys know, a global database, a global table with DynamoDB that I can use that just to replicate the data. This is a pretty good solution. I have now about 53 that's there on the top serving the DNS. As you see on the very top is that I'm still kind of an active passive solution here. So all the traffic's going to the left side to the region A, but if there is some sort of impairment in any of these components of that solution, I can quickly go there and switch, maybe using the region switch that Dan described before to take that solution and move from one region to another. So this is pretty cool, but it is still kind of just one region being active, the other region is being passive. So how can I enhance that solution? Before I talk about how to enhance that solution, I need to talk a little bit about the cap theorem. So the cap theorem is something that was created 25 years ago, and it tells us that whenever there is some sort of network partition, you have to choose between consistency or availability. Again, is that whenever there is some sort of network partition, such as when we are using multiple availability zones or regions, is that you have to choose whether you're going to focus on the availability side or on the consistency side. there. So now let me move that solution to be able to do active-active. So I change my Route 53 to be able to go there, send traffic to the two regions. Now the users across the different regions of the world can be served with the same kind of experience there. So the solution is sending traffic to both regions there. So we are pretty good there. And so are we done here? The answer is no. So if you look carefully at that solution, there is that even though all the components are running across the two regions, it is not a true active-active solution. Why? If you look at the pictures, that there is one component that is running primarily in one region, and it has a read replica into the other region. So the Aurora that we have there is that it requires all the writes to go to a single region. So you can have the read replica into the other region there, but with that solution, I'm still depending on region A to be able to go and write the records to my Aurora database. So how can I make this solution better? So what I want to describe is go and talk about Amazon Aurora DSQL. DSQL is a new kind of services that we introduced earlier this year, and allows us to be able to do an active write to database across multiple regions. Yes, it does require a third region to serve as the witness so that we can have quorum across the 3 different nodes of the Aurora DSQL there. But with this solution here, now I can go there and be able to write to region A and region B. Pretty cool. So now I have a service that we at AWS are providing to you that helps you to be able to implement multi-region there. But are we done? The answer is no. So Aurora DSQL is that it is something that we are going to manage the infrastructure and the scalability of the solution. It allows you to really do multi-active across the regions there. It does the automatic failover. So Dan described a little bit about the capabilities of application recovery controller to be able to implement the enablement and activation of the different regions. Here, no, is that we at AWS are going to do all the failover of the database for you. It is Postgres compatible, and one thing that I find super curious is that transactions are welcome, in the sense that we don't like to talk about transactions on the cloud, but here is the opposite, is that all the transactions or all the statements that you have in the transactions are going to be resolved locally inside that region, and whenever we do the commitment, the commit statement, that's where we are going to sync with the other side. So the transactions on Aurora's DSQL are welcome, and I encourage you to do those things there. Now, let's look at this diagram again. Latency is kind of awkward. Like, even if I stop here for 2 seconds and you don't hear any noise from me, like, okay, what's going on here? This guy's going. So what happened is that if you look at the DynamoDB global database, is that it is still doing the replication between region A and region B asynchronously. So the traditional mode that we have with DynamoDB, we call the multi-region eventual consistency, in the sense that the DynamoDB is going to persist the data locally to one region, and behind the scenes or asynchronous is going to replicate that data to the other side. As a consequence of that, there is a caveat whenever we use DynamoDB, the fact that the last one wins. So let's go to a scenario that you decided to store, for example, the credit balance of your credit card as a single record on your DynamoDB, and by coincidence, me and my wife decided to do a transaction at the same time. I'm here in Vegas, and I'm spending my $10 on my coffee, and my wife is spending her $1,000 on something else that she's buying there. And so if it happens to happen almost at the same time, is that we have the chance that in the property with Dynamo is that the last one wins. So whatever record has the most recent timestamp is going to be the one that's going to prevail that transaction. So you have to be careful whenever you're using DynamoDB with global tables, because it still has this property of the last one record that's updating a certain record will win. So in order to do that, there is another flavor now for DynamoDB, and it's a mouthful. The name is super big. It's called Multi-Region Strong Consistency, which means that the persistency of that data is being done not only into that region, but we are going to synchronously take that data and replicate to the other region there. So similarly to Aurora DSQL, is that DynamoDB multi-region strong consistency requires a third region to serve as the witness. synchronous there, so we do require 3 regions for that. But this way is that we have the guarantee that whenever you are storing the data in one region, the data first is persisted to the other side before we go back to the users there. So what are the benefits of DynamoDB Multi-Region Strong Consistency here? So it allows you to be able to implement a strong consistency across the regions there. It allows you to be able to still have low latency. So DynamoDB is famous for providing us low latency. Still with the strong consistency across the regions, we still have low latency. Certainly is that we have to wait until the round time to be able to send the data to the other region and be able to receive it acknowledged to that region. But DynamoDB is still multi-region strong consistency provides a low latency solution, and it simplifies your application logic. In order for you to compensate this idea of DynamoDB that the last one wins, you have to do some logic in your code. Maybe you write the data and then you read back to ensure that the data has been persisted there. Now with this idea of the MRSC, multi-region strong consistency, you can go there and have the guarantee that once you write the data is going to be persisted into DynamoDB. There. So I started my part here talking about the CAP theorem, the fact that whenever there is a network partition is that we have to choose between consistency and availability. So my initial solution was very simple, using just Aurora global database and a DynamoDB, what we call multi-region eventual consistency. So in that case, we are favoring availability there. So on the CAP trade-off is that we are looking for availability, and the consistency is eventual because it's done asynchronously there. The availability is high, and then we do certainly support partition there. But now with the new solution where I'm using DSQL and DynamoDB Multi-Region Strong Consistency, I'm focused now on consistency there. So in order to have a stronger consistency, I have to sacrifice a little bit of the availability. So as I told you, is that DSQL and DynamoDB Multi-Region Strong Consistency requires a third region, so you need to get quorum across at least 2 regions in order for that data to be persisted there with DSQL and DynamoDB Multi-Region Strong Consistency. So the availability is reduced whenever there is network partition there, but it's still something that we will be able to focus on consistency instead of availability. Yeah. So the key takeaways from the data consistency is that implementing resilient multi-region application is hard. And we talked about different aspects here, is that DSQL and DynamoDB Multi-Region Strong Consistencies help you with those things, as they provide ways to do synchronous replication of the data across the different regions, and it allows you to really do a true active solution across those regions there. And so it certainly is that in order to increase the consistency, we have to decrease the availability. So we have reduced the availability in the case of network partition. There. So one thing that Pran talked is about the technical recovery exercise. Is not really an exercise that my friends at Capital One does, is that it is really running the show in the sense that it will take the entire workload and switch from one region to another. And likewise is that my recommendation for you practice all your things that you're doing as if you are playing into the game. You don't like practice football by yourself by just kicking the ball and running and doing touchdown and things like that. So practice all your things, and maybe using Fault Injection Service as a way to help you with those things. But our recommendation here is that you practice your solution as if is it game day. So in terms of the call to actions that we have, is that as we talk to you here, is that dependency management is a hard thing to do, but you have to do it. It's impossible for you to create any kind of plans if you don't know the dependency across your components there. You have to automate your recovery. Don't do manual steps on that, but automate your recovery orchestration. And the last thing that I do, that I talk, is select your data consistency solution here, whether you're going to focus on availability or if you're going to focus on consistency. And if you're going to focus on consistency, now we do have some AWS solutions such as DSQL and DynamoDB Multi-Region Strong Consistency that can help you with that solution there. We do have a few white papers that feel free to take a picture, and they will help you in this journey of doing multi-region and resilient applications there. And we do have some swags available, not here. Oh, first of all, is that there is a meetup this afternoon, right then? Is that so all the resilience experts are going to be there. Feel free to join us at 5 p.m. today for the meetup on the resilience there. And we do have some swags. They are not going to be given here because we're supposed to leave this room as soon as we are done here. But Prem, Dan, and I are going to be available at the lounge area near the door here. So feel free to reach out to us and share your experience of doing multi-region and resilient applications and see how we can embrace on that journey together. With that, I want to thank you for coming to our sessions, and I hope you have a great day.